Okay, so this is for Unit 4, Objective 3, which is about adding and subtracting radicals. So in the Pearson book, it's actually Chapter 6, Objective 3, and it begins on page 440. So if you want to reference that while we take a look at this, that would be helpful. So a couple of key concepts before we get started, two of which are review ideas, but just to make sure that we know them. So the first review idea, so this is a review idea, and this is, I believe, from Objective 1, is when we are multiplying our radicals together, these do not need to be the same, right? They could be any value. So when we're multiplying, this could be a 2, this could be a 3, it doesn't really matter when we're multiplying. So when we're multiplying, we multiply the coefficient of the radicals together. So we multiply the numbers out front together, which are coefficients, and then we multiply together the b and the d. So when we're multiplying, we want to multiply first if the numbers are small, and then simplify second. If the numbers are large, we tend to want to simplify first. And then a second review idea is when we're multiplying two radicals together that are the same, so root a times root a, that's just equal to a, okay? So although these, when we multiply, is root a squared, because we have two of the same, we're thinking in our minds, oh, that should be absolute value of a, but because it's just an a here, that means it has to be positive, otherwise it would be imaginary. So then we don't need the absolute value. So it's not absolute value of a, it would just be a. Okay. And then our new idea for adding and subtracting is if we have two radicals that we're trying to add or subtract, I'm just going to write it as an addition though, but this applies to subtracting as well, is that the radicals must be the same. So it's very much like adding and subtracting variables. So if these are different, like a 2 and a 3, we cannot apply this property. So our front numbers, so we combine whatever a and b are, either adding or subtracting. So, and then our radical stays the same. Okay. So just to kind of real quick here do a variable idea review. So if I had 2x, say, plus 4x, I know that this is saying that I have two x's that I'm adding together. This is saying I have 4 x's that I'm adding together, right? That's just a shortcut way to say x plus x plus x plus x. So how many x's am I really adding together? I'm adding 6 x's altogether. And so here, if I had 2x plus 4y, this is saying I have 2 x's that I'm adding, I have 4 y's that I'm adding, so I'm not adding x's and y's, right? I can't do that, so this doesn't simplify and would just stay as 2x plus 4y. And so that's the same idea as radicals. So just as like a short little example, just to kind of remind us of each of these. So off to the side here. So if I have, so this is property number or key concept number 1. So if I have something along the lines of, say, 2 root 3, and I want to multiply that to 5 root, say, 7. So for multiplying, I would just multiply the 2 and the 5 together, and then the 3 and the 7. And then I would try to simplify, but I can't simplify 21, and so that would just be my answer. Okay. For the second key concept, if I have, say, root 13 times root 13, then that would just be equal to 13, right? So I could also say, well, this is just the square root of 169 using key concept number 1, and then what's the square root of 169? It's 13, but then I'm doing an extra piece that I don't need to do if I understand that when I multiply like radicals together, I just get the root of 13 squared, which is just 13, okay? And then just a simple kind of example, just to see the key concept, number 3, the new one. and we'll do more elaborate ones, but just to get the basic idea. Say that I have 4 root 2 minus 3 root 2. And so I'm subtracting, right? These are the same radicals, so that means I can go ahead and subtract. And so then I would just do 4 minus 3, which is 1, and then I keep the radical the same. So that would be the same as 1 root 2 or just root 2. Okay? All right, so that's just kind of the basic idea. So let's go ahead and do some examples here. Okay, so for this here we have 2 times the square root of 6x, and then we want to add that to the square root of 24x. So I just got done saying that our radicals have to be the same in order to add or subtract. So when I look down here, these are not the same. This is a 6x, that's a 24x. So that doesn't mean we can't do it, move on. It means we need to try to do something first. So what our first step needs to be, whether they're the same or different, is we always want to try to simplify the radical first. So I want to simplify the radical. Okay, and that's coming from lesson 1, right? So lesson 1 was all about simplifying radicals. So, and some of us have a hard time with this part. So, because we're trying to do, I think, too many steps in our head. So we want to always make sure we want to rewrite it first. So rewriting is not the same as taking square roots. All it's doing is breaking it down into things I can take the square root of. So we want to rewrite it first. So I cannot do anything with this 6 here because that's just 2 times 3, and I don't know the root of 2 or the root of 3. So then that would be 2 times the square root of 6x, right? And then for 24, I can rewrite 24 as like 3 and 8, 4 and 6, 2 and 12. But the only thing I know the square root of in all those combinations is 4. So I'm going to rewrite it as 4 times 6x. And I can't take the root of x. I can't split off an x because it's just to a power of 1. So then as soon as I rewrite it, now I want to actually do my square roots, right? So when I do my square roots, that's when I want to reduce everything. And I want to be attentive to what am I taking the square root of, what am I reducing? And that's what pulls out of the root. Don't rush through these steps or you're going to end up pulling things out that don't make sense. You're going to lose track of what you're trying to do. So being diligent on your steps and paying attention to what you're doing is really what's going to pull you through this. So here I have the 2 of, root 6x. I can't do anything about that. I'm going to go ahead and take the square root of 4 because I can, and so that would be just 2. So that is done, right? I can't take the square root of 6. I can't reduce that, can't pull it out, so it's going to stay where it is. And I cannot take the square root of x either because it's just an odd power, and I can't split one off. So the only thing I can reduce is the 4. What I cannot take the square root of is 6 or x. Okay, and so then now my last step is just combine, either through adding or subtracting based upon the operation, right? And so when we combine, we actually add or subtract our coefficients. And then the radical stays the same. Okay, so I'm going to do 2 plus 2, which is 4. And I'm adding roots of 6x, so I'm adding the square root of 6x, so that stays the same, right? So I have 2 square root of 6x's plus 2 more square root of 6x's, so altogether I have the 4 of them, and so then that would just be my answer there. Okay, so that's the first example. Okay, and let's do another one here. Okay, so we're going to go through and we're going to simplify first, right? So I look at 20, and I can rewrite 20 as 2 and 10, 4 and 5. And so again, the only thing I actually know the square root of is 4. So that means I'm going to rewrite. So rewrite, I'm not square rooting, I'm just rewriting everything. So everything's still underneath the root here. So 20 is 4 times 5. X cubed, that's an odd power, so I'm going to split off an x. And then move on to the next one. So for 45, I can use 9 times 5, 15 times 3. And I know the root of 9, so I'm going to use that. So 9 times 5. This is an odd power, so I'm going to split off one of the x's. And so that's what I have, right? So I've got 4 times 5, x cubed, split that up, 45, split it up, x cubed, split it up. So I haven't actually taken the square root of anything. All I'm doing is rewriting at this point. So everything is still underneath the square root. And now I'm going to go through and reduce and square root whatever I can. So I can take the square root of 4, which is 2, but not 5. I can take the square root of x squared, which is just x, because it's implied positive, because it's an odd power up here. And I cannot take the square root of x to the first. And so then this would be 2x. I reduced both of those, but I can't, so 5x. Move on to the next one. So the square root of 9 is 3. I don't know the square root of 5. The square root of x squared is x. And I can't do the square root of the odd power. So then this would be 3x, what I can't take the root of. And then now I've done square rooting, right? And so now I need to combine by adding or subtracting my coefficients. So that would be 2x and negative 3x, which is negative 1x, and my radical stays the same. And then that could also be just negative x root 5x, right? Because I don't actually have to have that negative 1 there. Okay? All right, so that's that part. And then the other part we're going to need to be able to do is distributive property. So this is still in the simplify category, so I'm just going to do this as example C. And this is, let's see here. Sorry, let me write down. What page am I on? Oh, page 443. I'm trying to figure out what page am I on. Okay, so this is the page 443 example in the book. So this is problem 4. Worked out. Okay, so it was okay. So problem number 4 on page 443. Okay, so basically this is going to require us to remember our distributive property. So our first step here is to distribute. So some of you, people might have said, oh, that's foiling, set it up like a box, but we're just going to do distributive property. And so we can distribute over adding and subtracting, but not multiplying or dividing or exponents, right? So over multiplying and dividing is something totally different. So we are distributing over addition, right? But this would also work for subtraction. So I'm trying to multiply these two terms over here with these two terms over here. So I'm going to multiply the 3 in this first group with both of these over here. So the 3 multiplies to the 2, and the 3 also multiplies to the 4 root 5. So we're using our key concepts here. So the 3 and the 4 can multiply together, which is just 12. And then the 3 does not distribute to the root 5, right? So it's just 3 times 4 and then root 5. So I multiply the 3 to both terms in the second grouping. And then now I'm going to do the same thing where I multiply the 2 root 5 to both of these. So 2 root 5 multiplies to both of these. So the 2 multiplies with the 2, but not the root 5. So 2 times 2 is 4, and then just root 5. And now I multiply 2 root 5 with 4 root 5. So when I multiply these two together, the 2 multiplies the 4, which is 8, But now root 5 times root 5 is just 5, right? That's the square root of 25, which is just 5. Okay, so then after I distribute, I'm going to simplify and combine like terms. So I'm going to do both, right? So I'm going to write combine like terms. And simplify, right? Whatever I can do to simplify this as well, right? Which is mostly what I'm just trying to do. So I have a 6 here. I know I can add these together because they both are root 5. And so I'm just going to combine by adding. So 12 and 4. And keep the root 5 the same. And then 8 times 5 is 40. And then if I look at this, I can add my constants together, so 6 and 40, so these two integers can be added. So 6 plus 40. But this is something I can't combine, right? Because this is an integer, while this is an irrational number. And so then I would just have 46 plus 16 root 5. And then that's my answer. Okay, and that's it for objective 3.